Hello and welcome to another tutorial on dev.java, and we are looking at the array types, which are built-in types. And now let's look at the copying arrays. Now the system class in Java has an array copy method that you can use to efficiently copy data from one array into another. And the signature of the array copy is public static void. So it's a static class, it's a static method. That's because this system class is basically a utility class, and whenever you have a utility class, what you want to do is make the constructor private and then make all the methods static, right? Now array copy doesn't return anything, so its return type is void, and what it does, it gets a reference as source, and then the start position of the source array, and then object destination array, and then the start position of the destination, and then the number of elements that you want to copy, right? So you start from some index in the source, and note that here it takes object, so it doesn't take any basically generic array type. And so for some reason apparently they didn't make this a generic type. And if you're not familiar with generic, it means basically what happens, you define a generic type, and then here instead of putting object, let's say you call the type t, and then you say that t array, right? So if I copy and paste this, and then let's go here and class, let's create a new class like my system, for example. You can have something like this. So you can have this method, right? So let me actually break it, and this is not abstract, so you have to provide some sort of body. So if I just don't provide any body and terminate it with semicolon, the compiler complains, says that this method requires a body instead of semicolon. What it means is that, hey, there is no reason any method has to have a body or code that represents the actions that the method does, unless it's an abstract method or it's a native method. So I'm going to provide an empty body here. I just want to show you that this is one way of dealing with this, but there can be another way, and that's a little bit more advanced topic. So advanced topic is generics, and what this does is that you say public static, before the return type you define a type t. All right, so you are parameterizing the method over some particular type, and instead of object you you mention a t array, and instead of object array you also mention t array, right? So this is another way of implementing this. Generics are called meta programming. Now Java decided to go in a very different route. Java went a very different route compared to C++. When it comes to meta programming or generics, Java went with something called type erasure. In Java we have type erasure. In C++ we have compiler instantiation. So in Java, in the bytecode, every t is, this type t is erased, and then the compiler in the bytecode at the compile time it deduces the most generic or the most general type that it can deduce, and then it replaces this. So basically, if you look at the bytecode, this is going to I believe have the same bytecode as this, because here we're not specializing or adding any bounds to t. Therefore what it does here is that the compiler assumes that t in the most general case becomes object. So basically this code in the bytecode translates into instead of having t, this will translate into the object array, right? And as you can see the compiler gives us a compilation error about duplication. It says that this method object array is a duplicate of this method that is generic. That's because in the bytecode this generic is actually translated into object array. Now if we give it some bounds, t extends for example number, this works fine because now the compiler replaces this generic method with the most general type that it can infer for t, which is number, right? So the compiler deduces it with number array. Again, this is I don't want to go deep into the details of generics. This is a more advanced topic and we will look at this, but in general they could write this utility method array copy as a generic, right? So it's just t, and then the problem is that they decided not the reason they decided not to do that because the way this array copy is implemented, and I'm going to guarantee that this has some calls to a native method, so it goes into the JVM and tries to basically this does a bitwise copy, bit to bit copy of whatever object is array is in the Java heap. The reason this is very efficient because we know that arrays are stored as a contiguous block in memory. So we already know how to quickly copy the bits of all the block, right? The index is just an offset to the references or the pointers that point to the first element of the array. Now here the problem is that we are specifying, instead of saying that object, we're specifying that an object array, and that's bad. That's very bad because this means this array is basically stores basically references. So this actually not works. For example, this method doesn't really work with primitive arrays, for example int array, because in Java this t will resolve to object array, not primitive. So this method, this generic representation of the method array copy doesn't work with primitive arrays. But this, if we just replace it with object, now this works, because regardless of what kind of object this is, then it's going to know that either a primitive type array is still an object. We look at this when we look at the let's see, did we look at it here, multi-dimensional arrays, and we said that regardless of what the dimension of the array is, it's always a subclass of object, right? So that's why they decided to go with the generic notation, and they know how to use the main copy. So in C we have a very efficient or C++, because C++ is also backward compatible, very efficient copy method called memcopy, and internally this method in Java is going to most likely invoke a native call, and that native call is going to use memcopy and just takes this chunk of memory that the array occupies, the data of the array. We said that arrays in Java have a little bit of header. It keeps track of their lengths, but here we don't care. We don't want to copy the length of the source to destination. So internally in JVM it knows which byte to start with and pass to memcopy to copy only the data, right? So let's open up this memcopy, basically this system. I'm going to open it up from JDK 16, and let's look at the let's see, copy. So array copy. Here's the array copy, and as you can see here, it says intrinsic candidate which means they already have hard coded this native call. And as you can see, in the website they don't mention this is native because they didn't want to confuse you, but in fact this array copy method is a native method, which means that this directly reaches to the C++ implementation. Basically JVM is written in C++. So, and then I'm pretty sure that this is going to call some sort of the C++ API, most likely the memcopy, that just copies the arrays, raw arrays, primitive arrays, right? Because that's the most efficient way of copying bytes of memory from one array to another, and you don't worry about the rest, right? So the source array, let's look at the API. It says that maybe let me open it up in Java doc. Let's go to Java doc. So array copy, class system let's search for array copy. Java lang system array copy, public static void array copy object source object destination, source object destination int length. I'm not sure why it drops the native public static void array copy, public static void array copy, but for some reason it drops the native from the declaration. But that's fine. This is a native, which means when you have a native method, you don't provide any implementation, and the JVM loads a dynamic library, and then basically the implementation is inside the C++, right? And then if you are wondering what the dynamic library is, so if I go to the JVM, look at JDK 16, content, macOS, libjli.dylib, right? This is the dynamic library associated with the JVM. And inside this, there is all these native implementations, right? So you have your JDK, but in the lib, you have a lot of dynamic libraries that are implementing part of the native codes that the JVM needs to be able to run. For example, AWT, all of the Java AWT is you really need native calls to be able to talk to the operating system. That's why these dynamic libraries exist, right? So if you ever wondered what these dynamic libraries are, these are basically that part of the JDK or Java that have implementations of the native calls, because eventually you have to be able to talk to the operating system, talk to the hardware, anything that goes to operating system, anything that interacts with the operating system, anything that interacts or tries to use some sort of resources like hardware, sockets, IOs, everything has to go through the operating system. And all of the operating systems at the moment are written in C or C++. So you have to, and they always provide some sort of C or C++ API. So you have to interact with them. That's why all the higher level languages like Java, Python, anything else, they always have some sort of foreign function API or basically FFI, foreign function interface. And that's why they can always have a way of calling C or C++ functions and passing data between them, right? So this was just a brief detour here, but this array copy is native. Copies an array from the specified source array beginning and the specified position to the specified position of the destination array. A subsequence of array components are copied from the source array reference by source to the destination array reference by dest. Again, just note that the source and destination, the signature is object, not object array, and it's not parameterized. There's a good reason for that, because you really want to copy the bytes that these arrays, the data part of these arrays occupy in the memory, right? And the mem copy that C++ provides is the most efficient way. The number of components copied is equal to the length. And remember, one thing that I want to point out is that one of the limitations of this int array, basically arrays in Java, is that some people may consider this as a limitation, but I mean in almost all practical use cases you won't really care about this. But the problem is that arrays, basically array length only supports int type. What this means is that you cannot use line type, which makes sense. So even if you have a byte array and then let's say b1 equals new byte array, and then let's say we specify 100, right? So this index basically also indices, not only length but also array indices are only int type. So you cannot use a byte or short or long, for example. Now, if you specify a small type, let's say byte b index equals 2, and then I say b1 b index equals 10, for example. Now this works because byte can be implicitly converted to int, and anything that goes between the square brackets for the indexing in Java has to be int type. But if I say this is long, and the compiler automatically converts this, but the best practice is that to specify that this is a long literal. Now the compiler complains. Why? Type mismatch, cannot convert from long to int. What does this mean? It means that the indices of the arrays has to always be int. That's a given. That's built into the language. That's cooked into the language itself. Now you might say, okay, maybe I want some array that has a length that is larger than the maximum that the int can support. Unfortunately, that's not doable at this point. Java doesn't support long, and for good reason, because think about the amount of memory that an array can support, right? So what is the maximum integer.max value? So what is the maximum value that the integer can support? It's this one, right? So let's say int max val, and this, let's say now I have the smallest array size that I can have is a byte array, right? And each byte, let's say, maps to 1 byte. So how much this is in bytes? So 3 digits, 3 digits, 3 digits, right? So let's say this kilobyte, megabyte, gigabyte, terabyte. So an array can the maximum size an array that at the moment Java supports is 2 terabyte, which is ridiculous, right? You will never ever have an array that has a size more than 2 terabyte. It doesn't make sense. Now obviously if you go for example to an int array, which is a more typical case of arrays, right? We typically don't use byte. By default we use int, and then what happens here is that you have to multiply this by 4, right? Because each int is 4 bytes, and then you end up with actually that even if it overflows, right, it goes to -4, because we probably need to convert this to long, for example, to make it prevent it from overflowing. If you don't know what overflow is, we discussed this in depth in the previous lectures. So max value times 4, I guess we convert the max value to long and then multiplied by 4. Yeah, and this is like 8.5 terabytes of memory, which is you will never have. So Java at the moment only supports int indexing. Indices should be int, and that could be a limitation if you really want to push the size of the arrays, but at the moment that's the limit. All right, so array copy, we said that let's open up the system class again. This array copy takes objects and it just calls a native. If you don't know what the intrinsic candidate is, intrinsic means that it's implementation details of the JVM, and it usually means that there is some hard-coded part of the JVM that knows exactly how to do this, right? And it makes sense because this array copy, it just can directly call that memcopy from the C++ library, and then memcopy is the most efficient way of just copying bits around, right? So they know how to do it, so they didn't really know to do any special implementation. So JVM sees this call and says, okay, I know exactly what to invoke, and it directly goes to and invokes this memcopy to copy the bytes. That's it. That's more or less the meaning of intrinsic, which means there is no special code. It's the most efficient code is already available in the JVM. That's part of it. So these methods, for example, array copy doesn't get JIT compilation, but pretty much any native method doesn't get a JIT compilation. There is really no optimization. That's why they also mark this with intrinsic candidates, saying that, okay, this will never get JIT compiled, but don't worry about it because we have already implemented the most efficient way of doing this array copy. That's why it's marked with intrinsic candidate annotation. At the moment, JVM treats all the native methods as black boxes. It doesn't do any JIT compilation. It doesn't monitor the calls to native calls because Whenever you call a method, usually JVM keeps track of how many times the method is called, and then if it passes a threshold, it adds a level of tier compilation, maybe tier 1, tier 2, tier 3, or tier 4, doesn't matter. C1 compiler or C2 compiler, some sort of compilation happens, some sort of incremental optimization as the time passes by and more calls to that method happen, right? But that's not true for the native methods. Native methods, JVM doesn't just care about them. So you want to make sure if you implement a native method and you go to the C or C++ or the native world, then you want to make sure that you have the most efficient way of implementing that. All right, back to here, copying array system, and note that this array copy, which exists in the system, it also exists in the arrays class. I'm going to open it up from so copy. Let's see, does it have array copy? System array copy system. So it has a lot of copy methods. So if you look at the copy of, and note that these are now generic, because now these are type safe. The upside of generic is that it's type safe. The downside here is that your object, it's not efficient, because you cannot really use generics with that, because Java doesn't support primitive generics. So everything has to be objects. That's why they also specialize on the primitive array types, right? And all these, as you can see, it delegates the call to system array copy, which takes an object. Copy of int, long array, char array, float, double, boolean. Again, one of the downsides of type system is that, and the way Java handles generics, is that generics always translate to references, so they do not support primitives at the moment. And then you have to specialize on the primitive types as well, right? Float, double, boolean. So my recommendation is that use the arrays class to do array copying. Don't use the system array copy, because arrays class has all these copy of utility methods which specialize on the types, and then it's also type safe. So whenever you deal with an object, it's not type safe. Plus here you have to specify with the offset index, which most of the time you don't want that. So the two object arguments specify the array to copy from and array to copy to. The three int arguments specify the starting position in the source array, and we usually call this offset. So whenever you have an array, obviously the reference to an array or the pointer always points to the first element, and after that the index means an index into the array means there's an offset, right? You want to start sometimes from an offset and then copy some number of elements. Here it's called length. Maybe calling it number of elements would have been more telling, more clear. The starting position in the destination array and the number of array elements to copy. The following program, array copy demo, declares an array of string elements. It uses the string array system array copy method to copy a subsequence of array components into a second array. So we declare an array, we directly initialize it, right? So no problem there. The compiler confers the size based on the elements in the initializer list, and then we specify another array with some different lengths, 7, at system array copy from index 2. So this is the third element. Remember, indexing starts from 0, and copy 2, we copy from index 0 and 7 elements. So we fill this up from the third index, and then you see third, fourth, fifth, 6, 7, 8, etc. So we start from this one, which is the third index, and copy them. All right, so this was all the details about copying arrays. Again, the recommendation: use the arrays class instead of directly using system array copy. So arrays provides a copy of, and all of these delegate to basically some sort of system array copy call. The good news about this copy of methods is that they are type safe, so you don't worry about the types. If you pass a double array, you will get a double array back. If you have an object array, then you can use this one, and it's a generic type. So whatever type you put in, for example, a string array, it gives you back a string array, right? So I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one.